Well, the Extreme Ice Survey monitors changes in the glaciers in a lot of different parts of the world. We have time-lapse cameras out in Greenland, Iceland, Montana, and Alaska, and around Mount Everest. We also do what's called repeat photography. We go back on an annual or biannual basis to the Andes of South America, to the Alps, to British Columbia. And what we're watching for is how the ice is changing in response to climate change. The Khumbu Glacier on Mount Everest is a very interesting site because it's, of course, Mount Everest, the highest peak in the world. And the Himalaya is, at least the central and eastern Himalaya, is seeing a tremendous change in ice as well. So that's sort of the water tower of the world, as it's referred to. And there's a billion to 2 billion people who are connected to water supply that comes out of those glaciers. So it's of great interest to us to see what's happening. I love pairing these digital globe satellite pictures with what we see down on the ground. You know, the high view gives you this big perspective and this spectacular detail, and then the ground level view that our time-lapse cameras see gives us a real-time view of how the landscapes are evolving, sometimes on an hourly basis in response to climate change. So it's a very powerful marriage of two kinds of viewing, two kinds of perspectives. The Ilulissat Glacier in Greenland is the single most important glacier in all of Greenland. More ice comes out of that fjord than from any other site. And it's been retreating tremendously, dumping a huge amount of ice into the ocean. And in fact, the iceberg that almost a century ago sank the Titanic is believed to have come from that fjord. At most of our sites, we're seeing amazing changes in these glaciers. We're seeing the terminus of the glaciers, the end of the glaciers retreating back up valley, and we're seeing the surfaces deflate. It's like air being let out of the balloon, and that's response to less snow coming in up in the headwaters of the glaciers. So these to us are very, very clear indicators of a landscape changing in response to changing climate. This is not an abstraction. That's what's so powerful about these pictures and about this observational record. This is not computer models. This is not a projection into the future. We're seeing it happen right now. Our site in Iceland is another very important place where the glacier's been retreating for the better part of 70 or 80 years. And it's also an incredibly beautiful spot when seen from satellite perspective. I mean, I've been to that place a dozen times in winter and summer and fall and spring, and still I've never seen it look as beautiful as it does from that huge high perspective looking down on that great cat's paw of ice as it rolls off this big volcano and drops into the ocean. Glaciers are these incredible barometers and thermometers of regional climate. They respond actually incredibly quickly to changes in their environment. You know, there used to be this old term, glacial pace, you know, to suggest that glaciers are very slow-moving animals. In fact, what we've discovered over the past few years is that they can move very quickly in response to daily and hourly and certainly to weekly and monthly changes in weather. You know, our focus is going to stay pretty much as it is. We have these very carefully chosen sites that are representative of large regions around the world. We'll keep monitoring those same positions and amassing a record that's longer and longer and longer. And the longer it is, the more persuasive and the more powerful it is. And I look forward to this continuing relationship, this marriage between digital globes pictures and what we're doing on the ground. I think it's an incredibly powerful record of this decisive moment of historical change.